In this video, we are going to talk about perfect squares. And we're going to start out by talking about just the shape of a square. A square is a four-sided shape. A lot of you guys in class today remembered the word quadrilateral. Quadrilateral. And what's important about today is that all four of the sides are equal in length, or the same size. There are a lot of other things about squares, the shape of a square, that we're not going to talk about. Most of you have it in your head that square means four because there's four sides, and that's not the case. A square number is the product of an integer in itself, and remember that a product is just the answer in a multiplication problem. So looking at this example, 9 is a square number because I'm taking an integer and multiplying it by itself. 3 times 3, a number times itself, is 9, which means 9 is a square number. Sometimes we call square numbers perfect squares. Square numbers or perfect squares represent the area in a square. A square root. The definition of a square root is a little bit tricky with the words. The number a is the square root of b if a times a equals b. Let's look at what that really means. This is talking about the square root of b, and that is a. Is means equal, so we're saying that a is equal to the square root of b. That's true if a times a is b. So looking at my example here, this says 3 is the square root of 9 because 3 times 3 equals 9. 3 is in place of a, so I'm saying that 3 would be the a in that little problem. And is the square root of 9 is the square root of b, so 9 would be b in that problem. So then we have a times a equals b. 3 times 3 equals 9. So this is really saying that the square root of 9 is equal to 3 because 3 times 3 is 9. Circle that bullet point and say side length. And I don't have room for picture over here, so we'll go off to the side here. And that's what this is, essentially. When you take the square root, you get this one side length. The area of a square, most of you are saying length times width, or if you liked the 6th grade version better, base times height. But in a square, all of those sides are equal. L and W are equal. B and H are equal. So instead of using those letters in 8th grade, we're going to say that the side length of a square is S. And so instead of length times width, since those are both S, I can say S times S. But when we have a number multiplied by itself, that's a squared number. So S squared is the area of a square. In a normal year, we'd have some of these to play with on our desks. We have a square tile. So I'm going to draw the one square tile. And the side length here is 1. The area, you can see, is just one square. So there's an area of 1. Let's talk about finding the area using this formula, though. A is S squared, which is the side length times itself, which is 1 squared, which is 1 times 1, which is 1. This is an area, so the units are squared as well. And on the side length, that's just 1 unit. The second example here says that using 4 tiles, let's make a square. So now I've got 4 tiles, and I need to arrange these so that I get a square. This is a square because I've got 2 by 2. So both of those side lengths were the same. So I'll draw the square that we made. And each side is 2 units long. The area, you can see we used 4 tiles, so that would be 4 units squared. We also know that the area is just the side length to the second power. The side length squared. The side length here is 2. 2 squared is the same as 2 times 2, which is just 4. Now we want to use 9 tiles to make a square. So I'll get out my square, and I need 5 more tiles. 1, 2, 3, 4, and 5. Okay. I'm going to start by doing that. Well, that's a rectangle, not a square, so I can't keep adding over here, otherwise I'm never going to get to that square. So I'll add 1 below and fill in that square and see if that uses all of my 9 tiles. And it does. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I had a 9 tile square, it looked like this. 1, 2, there we go. We had 3 squares by 3 squares. The side length was 3. And we had a total of 9 squares in the area. And we actually see that mathematically with numbers. When we look at the formula, A equals the side length squared. So instead of S squared, we can write 3 squared because S is equal to 3. And that's just 3 times 3, which happens to be 9. I'm going to get back that 3 by 3 square. Now we want to use 16 tiles to make a square. Oops. These are not all cut very evenly. Okay, so what we have here is a 3 by 3 square. I can add another row, or column I mean. But when I do that, then I've got 4 columns and only 3 rows. And that's not a square because those would have to be the same number. So I'm going to put my next tiles as another row. And hopefully this completes a square, or I'll have to add another column and another row. This does complete a square, and this is all 16 tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's a 4 by 4 square. There we go. So this is our 16 tile square, and the side length you can see is 4. And we know that the area is 16 because we used 16 tiles to make it. However, you can see that more logically with the numbers. The formula for area of a square is S squared. The side length is 4, so instead of S squared, we can write 4 squared. That's 4 times 4, which is just 16. Before we move on, I want to look at, just for funsies, the square root of 16. The square root of 16 is 4, because 4 times 4 is 16. In this box, let's look at the square root of 9. The square root of 9 is 3, because 3 times itself gives us 9. In this box, let's look at the square root of 4. The square root of 4 is 2, because 2 times 2 is 4. And then in that first box, we want the square root of 1. The square root of 1 is 1, because 1 times itself is 1. Now what I want you to see here is that we are taking the square root of the area. And when we do that, we're getting the side length. When we are taking the square root of the area, we're getting the side length. Again, the square root of the area would be the square root of 4. The square root of 4 is 2, but the side length was also 2. We are taking the square root of the area, and the answer there is whatever the side length is. What we're finding is that the square root of the area is really just the same thing as the side length. Now in these examples, we have, the area is a whole number. The area is a whole number, no decimals. The side length is a whole number, no decimals. If I was to have a square using 5 tiles, let's use 5 tiles. 1, 2, 3, 4. There's nowhere that I can put the 5th tile to really have a perfect square. It wouldn't even be a rectangle or a quadrilateral. So I could split this up and put it all around to keep a square. But that's not a perfect square because I can't use all of my tiles without breaking them up. So when the side length is a whole number, or an integer, when the side length is an integer, then the square is perfect. The side length is just a square root, so we could say that when the square root is equal to a integer, when the square root is equal to an integer, then the number that we took the square root of is perfect, or is a perfect square, or a square number. Let me zoom out just a little bit. That's not where I zoom. Oh, that's already all. Sorry, you're going to have to pretend you can see what I wrote. You can pause the screen and look at that. Okay. These examples ask us to determine which numbers there are perfect squares. So I want to know, when is my number a perfect square? That's whenever the square root is equal to an integer. So we're taking the square root of all of these numbers. The square root of 4 is 2. Since 2 is a whole number, 4 is a perfect square. The square root of 12 is not a whole number. The square root of 12 is between 3 and 4, and it's a little bit closer to 3. I believe you get something like 3.40, and that irrational number keeps going forever, non-terminating. Since the square root is not an integer, it's an irrational number, it's not a perfect square. This would mean that the side lengths would have to be 3.46. I can't show you 3.46 tiles without cutting a fourth tile in some itty-bitty pieces. The square root of 25 is 5, because 5 times 5 is 25, which means 25 is a perfect square number. 48, this is where a lot of you are saying, well, 48 is 12 times 4, so it's perfect. That's incorrect. Square does not mean 4. You need to take the square root of 48 to see if this is an integer or an irrational number. The square root of 48 is about 6.9, and then that is also non-terminating because it's square root equal to a decimal. Square roots equal to a decimal are non-terminating, non-repeating. Those are irrational numbers. We talked about that a while ago. However, since this square root is equal to not an integer, this is not perfect. 48 is not a perfect square. 48 is not a perfect square. The square root of 100 is 10. 10 is an integer, so 100 is a square number. Notice that 100 is a square number, not the square root of 100. 100 is the square number because its square root is a whole number, or an integer. Sorry. Next, we want to look at the square root of 121. I want to know if 121 is a perfect square, so I take the square root of it. The square root of 121 is 11, which is an integer, so 121 is a perfect square. The square root of 150 is a decimal. Since this is a decimal, it is not a perfect square. The square root of 225 is 15. Since the square root is a whole number, an integer, 225 is perfect. We're doing that exact same thing in the next box. We want to know which are perfect squares. I want to know, is 1 a perfect square? So I take the square root of 1, which is 1. Since the square root of this number is an integer, that number is a perfect square. 1 is a perfect square. I want to know, is 5 a perfect square? So I take the square root of 5, and I get a decimal. Since I get a decimal when I take the square root of that number, that is not a perfect square, or 5 is not a perfect square. Next, I want to know if 16 is a perfect square, so I take the square root of 16. The square root of 16 is 4. Since the square root of this number is an integer, then this number is a perfect square. So 16 is a perfect square. 50. I want to know, is 50 a perfect square? So I take the square root of 50 and I get a decimal. Since that's not an integer, 50 is not a perfect number or a perfect square. Next, I want to know, is 80 a square number? So I take the square root of 80, and we get a decimal. Since the square root of 80 isn't an integer, it's not a perfect square number. Next, we take the square root of 122, because we want to know, is 122 a perfect square? When you take the square root of 122, you get a decimal. Since the square root of this number is a decimal, that's not a square number. Now we're looking at 169. We want to know, is it a perfect square or is it a square number? So we take the square root of 169. The square root of 169 is 13. Since the square root of this number is an integer, this number is a perfect square. 169 is a square number. I want to know, is 250 a perfect square? So I take the square root of 250 and we get a decimal. Since the square root of this number is a decimal, this number is not a perfect square. We're going to use what we've seen in the first few examples to now draw a square with a side length of 8. But instead of having 8 square tiles by 8 more square tiles, I'm just going to draw one big square. I'm going to label its side as 8. So I know the side length is 8. To find the area, I can use the formula. The area is the side squared. That would be 8 squared. 8 squared is 8 times 8, and 8 times 8 is 64. This is an area, so the units are squared, and that was really 8 units, not just 8. Now I want to draw a square with an area of 64. Here's my square. 64 I'm going to put on the inside, because area tells us the space inside of that shape. So I know that the area is 64. And that's an area, so units squared. We found that if we square root the area, we get the side length. So to find the side length, we're going to take the square root of the area. Well, the square root of the area would be the square root of 64. And the square root of 64 is 8. So the side length is 8 units. So no matter which information you start with, you're going to end up with the same answers. 8 as a side length means that 64 is the area, and vice versa. If the area is 64, then you know the side length is 8, because squares and square roots are opposites of each other. Next, we'll look at a square that has side lengths of 12 units. The side length is 12 units. So the area can be found by taking the side length and squaring it. That's the square of 12 units, or 12 times 12 units squared. 12 times 12 is 144. Units got multiplied by units for units squared. That's why we get an area of units squared here. Or that's why for area units are squared. Looking at my square, now I know the area is 81. So that's an area of 81 units squared. We're working backwards again, so I want to find the side length when I know the area, which means we just take the square root of the area. The square root of the area, in this example, is the square root of 81. The square root of 81 is 9, so the side length is 9 units. That's all for the front of this page. This is page 101, front on our binders, in our binders. When we flip this over to the back of the page, we have some basic squares that we should probably memorize as 8th graders. And maybe we can see all of them here. It's really hard to see. We can almost see all of them. Okay. So to find 1 squared, we would use 1 times 1, and 1 times 1 is 1. To find 2 squared, we look at 2 times 2. 2 times 2 is 4. To find 3 squared, we do 3 times 3, which is 9. 4 squared would be 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. 10 squared is 10 times 10, which is 100. 11 squared would be 11 times 11, which is equal to 121. 12 squared is 12 times 12, or 144. 13 squared, 13 times 13, is 169. 14 squared is 14 times 14, is 196. 15 squared is 15 times 15, 225. 16 squared is 16 times 16, which is 256. 17 squared, 17 times 17, which is 289. 18 squared is 18 times 18, which is 324. 19 squared is 19 times 19, which is 361. 20 squared is 20 times 20, which is 400. And the last one I want you guys to memorize is 25 squared, or 25 times 25, which is 625. You will be quizzed over these frequently in the coming days and weeks. These are our new math facts as 8th graders. In elementary school, you learned how to add and subtract, and you memorized some basic facts. You learned how to multiply and divide, and you learned some basic facts. In 8th grade, we're learning squares and square roots, and we're going to learn some basic facts. And we need to be able to recall those really quickly. To kind of help with that, there is a small pattern that I think would be worth looking at. So we'll zoom in real quick. We'll make this clearer. There we go. All right. When I go from 1 to 4, you add 3. What do we add to go from 4 to 9? We add 5. To go from 9 to 16, you add 7. To go from 16 to 25, you add 9. You can notice here that every time we get another square, we just add 2 more, or we add the next odd number. So next we're going to add 11, and 25 plus 11 is 36. Adding 2 more to that would be 13, or the next odd number is 13. And 36 plus 13 is 49. I would then add 15, and 49 plus 15 is 64. That pattern continues. I want to talk about if you are working all of those out, so you're adding 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39. How come when I go from 20 squared to 25 squared, I don't add 41? You'll notice that when I was increasing the square number, I was just increasing the integer by 1. 1 squared went to 2 squared, went to 3 squared. You're just adding 1 here. But when you go from 20 squared to 25 squared, you're skipping 5 integers there. So when you're adding, if you choose to use this method, you do need to be careful, because when you add, you're going to try to add 41 here to get to here, and that's not going to work. Adding 41 would get you to 21 squared. Adding the next one would be 43, would get you 22 squared, and so on. I just think that that's a neat pattern that you should make note of in your brains. This was a relatively long lesson on perfect squares. Your homework, before I go on to that, this is page 101 on the back. The homework is front and back. It's relatively simple questions. All of the examples can be found through your notes. If you do have questions, comments, or concerns about the content in this video, please reach out and message me on Schoology. You can email me or drop a comment on this video, and I'll get back to you as soon as I can.